Henry's recording and transcribing now.
Okay. I'm good to go, right? Yeah.
Yes.
So, okay. Let's begin with a bit of definition. What is data and data analytic? Data, we use data every day either for work or for other purposes, and data can be described as a set of informations that contain both qualitative or quantitative. Qualitative meaning can be good or bad. Quantitative is normally a continuous like measurements data. And mostly data are being reported in two forms. One is tabular, to provide a quick summary of information, and the other one is graphical. As more and more common that we see in the internet in other forms, you have either a static graphics or a dynamic with the interest of time. So in essence, data analytics is the science of analyzing that raw data to make conclusions about the information. It involved the collection, transformations, if you will, and organization of data to draw the conclusions, to make predictions, and finally to drive the decision making. So we like to use the journey to excellence similar to data analytics. As you can see on your x-axis is describing a complexity of your data analytics. So obviously from the left to the right, the complexity is increasing. By increasing the complexity, you also get the value being generated. So if we start with data reporting is concerned about what happened, right? So if I can use the example of production throughput, it's interest in knowing what kind of throughput did I make yesterday, the day before, the week, or the week before. And then if we move on to the next level of data analytics is data analysis. Now we are starting to get more concerned about why did it happen? Like why my throughput is yesterday was better than the day before or the week before. And is there any significant variables? Now we're looking at any significant variable in our data analysis that affect our throughput, in this case, our throughput. So if we move on to the predictive analytics, we are trying to answer that question of what can happen, meaning that if we notice something in our data analysis, a certain range that really good performance, then if we can control our input or can control in a certain range, what can happen to our output. And finally, for data optimizations, how it should happen to deal with a lot like if you add another equipment, machinery, how can we achieve the performance? How much throughput can we get? Or other example, if we are changing from a 2 shifts of 12 hours to 3 shifts of 8 hours, how much cost benefits can we generate it? It has to do with a lot with what if analysis through the simulations. So those are the data optimizations aspect. So if I can put it in a table, data reporting in general also called descriptive analytics. And the time that we are interested is in the past, right? And reporting translate the raw data into informations and typically can identify the area of strength and weakness in your organizations. The questions to do with the data analytics deal with the input and the output. Typically focus in data reporting is mostly about report KPI, key performance indicators, and the tools that we generate is the graph, the dashboard, and the simple statistic. One of the limitations in data reporting is it does not provide any insight. It doesn't go deeper on the things that you're really interested. It's just report. This is one of the example of data reporting dashboard that we created for a client of ours. So it kind of summarize the 12 months period of your, in this case, is your throughput, your grade and recovery. On each of the bar graph, you can quickly see what is the budget, the forecast, and the actual. You can compare if there's any deviance from your forecast from your actual. So like I said before, data reporting gives you a quick summary of your things that you're interested. Another example of data reporting is financial statements. We have seen a lot, like it's being typically put into a tabular form. And in the daily life, we are very familiar with the mortgage rate trends over the time. Those are aspects of data reporting. If we move on to the next stage is data analysis. Data analysis is also better known as diagnostic. And the time of interest is still in the past. Now we are starting asking questions about why did it happen? What are the relationship between the input and the output? Is there any significant variables, right? So the focus is we're starting to use root cause. Another technique is 5 whys, by asking 5 different why to get to the root cause. And some of you might be familiar also with the technique of fishbone diagram or cause and effect diagram. And now the tools that we start to use is more advanced statistics, software being used, for example, is Minitab. We also use a lot of spreadsheet and data mining. One of the approach of data analysis is correlation and regressions. Correlations measure the degree of associations between the key is two continuous variables. An input to an output, it can be 2 inputs or 2 output against each other. So it determines the strength of the linear relationship. However, a strong relationship other than linear can also exist. A high degree of correlation does not establish causations, cause and effect. For example, if I can use an example of number of skiing accidents in our area, like Blue Mountain, is highly correlated with the sales of warm clothes, right? There's a positive trend. However, buying warm clothes did not cause any accidents. And regression is measure the strength of the association between independent variable, which is typically our input, and a dependent variable, our output. The difference between correlation and regression is regressions we have equations that being put up. Regression can be a simple regressions and multiple linear regressions. Simple meaning you have only one input and one output. Multiple, you have multiple inputs that affects one output. Today, I would like to use the example of copper concentrate recovery as our product. So data analysis being performed is using the technique of ANOVA, analysis of variance. ANOVA is performed using a statistical tool. So ANOVA is the input is a discrete variable, meaning that, for example, discrete variable is the crew. You have 4 different crew working in a factory or in a plant, or a season. You have season like fall, winter, spring, and summer. And the output is continuous. Over here, my output is a copper concentrate recovery. So a bit of background, copper concentrate recovery is typically being influenced by the following variables. A discrete can be season, crew, particle size, and the continuous data, obviously throughput, feed grades, and availability. In doing data analysis, it's important to have enough data. In my case, I use 12 months data. in order to represent the true operating conditions. And also you can use, the key here is to use the data that you understand the most. If you have been with a company for 2 years, then use that 2 years. Otherwise, you do not really know what's going behind that if you use 5 years or 10 years of data. So before ANOVA, analysis of variance, can be performed, the first thing we need to do is to check if the 4 different set of data, discrete data, are more or less the same. So over here, we use a technique called test of equivariance. How do we know that they are more or less the same? One is to look at the graph, that those 4 different buckets of data are more or less overlapping each other. And the other measure we use is a p-value. If the p-value is above 0.05, it means that it's not statistically significant. Over here, my p-value is 0.177. So the output of the ANOVA is, if you can see on your left graph, they indicate that your copper recovery for the 4, on average, it's between 83 to 85. And if we look at the spring, on average, you have a recovery between 79 to 83. And if you also look at the winter has an effect compared to the spring. So those periods are different compared to the spring. Fall and winter is different than the spring. And also in terms of is statistically significant. As you can see, is the p-value is less than 0.05. A good practice to do ANOVA on is to look at also the residual plot. The intent of residual plot is we want to make sure that there is no trend, or what we want to look at is randomness. For example, if you can look at the right-hand graph, the right bottom of the graph, we want to make sure that there is no trend on our observation order versus the residual. So you can see the data is going in the positive and also in the negative. So it's not going in one way or the other way. And also the versus fits. So the data points are between 0 and positive and negative. So in that particular examples, we noticed that for copper recovery, seasonality has an impact on your copper recovery concentrate. So if I may recap, on data reporting, descriptive, it is the most basic level of analytic, and as a lot of organization, we spend the most time of this stage because it only deals with what happened type questions. Data analysis allows you to ask why it happened and answer which input or variable input influence the output. So the correlations. So in the next webinar in May, I will like to discuss the last 2 stages of data analytics, which is predictive and prescriptive, or data optimization, where the time frame is about the future. That's it about my webinar. Any question?
Yeah, Henry, I have a question for you. Some of the new things happening with artificial intelligence or big data, does that impact some of the stuff you were presenting today?
I think it does, because a lot of the AI, they are looking for a lot of correlations, right, Carmen? It's just I have to be careful. As I mentioned in one of the slides, the correlation doesn't mean causations. It's just trying to find different correlations, and if something correlates doesn't mean it's the truth, right? So we just have to be careful with that.
I see. Okay, thank you.
Any else? Anybody else?
Thank you, Henry. That was informative. Appreciate it.
Thank you, Sharon. Thank you for coming. Appreciate it. Yeah, if you have any questions, if you like me to go deeper, or I welcome suggestions and inputs to make it better, especially in the last two stages would be very interesting.
Thank you, Henry. Just one, I guess, point for me is when you speak about the last two stages, could you also talk about some of the tools that might be available, commonly used tools that would be used? Yeah.
Yes, yes.
Thank you.
I guess it's a bit short for the presentation, short and sweet, I would say. And if there's no more questions, I will end this webinar. Thank you all for coming.
Thanks, Henry.
Thank you.